Hello everyone, welcome back to Math Zone African Motives. We are still on our O-level mathematics working with matrices. So this is going to be an introduction to the matrices that is basically according to our syllabus. The matrices you are going to need to know the dimension or the order of a certain matrix that is use and interpret, all right, a matrix as a store of information and show familiarity with the idea of dimension or order of matrix, of a given matrix. So that is the basic part that you're going to actually work with for the introduction. But for other classes that you're going to work on after this is going to be on the operations, where you're going to work with addition and subtraction. All right, that is, you must add and subtract matrices where appropriate, meaning to say there are conditions where we cannot add or subtract matrices. All right. So it is basically considered from the dimension or the order of a what? Of a matrix that is going to help us to perform that addition and subtraction, as well as to multiply by a scalar. All right. So we have scalar multiplication, just like what we had before, working with vectors. We had scalar multiplication. Again, under these matrices on the operations, we need to multiply matrices of order 2 by 2 or less, right? So basically, according to your syllabus, 2 by 2 or less, that is what you're going to work with where appropriate, all right? Then also understand what is an identity matrix and use the property of identity and zero matrix of 2 by 2 matrices. They have special properties. What are those properties in calculations? All right. Then also the determinant. Find the determinant of a 2 by 2 matrix and distinguish between singular and non-singular matrices. You must be able to differentiate between the two, all right, and use the notation determinant A or determinant of A in this, like det of A in short. And this presentation, like we saw before on vectors, we had this presentation for the magnitude. But this time, when you see this under matrices, it is for the what? Determinant. So this is the notation for the determinant, or you can write in short like this, or you can write in full determinant A using these notations. We are going to apply them and also to determine the inverse matrix, that is find and use the inverse of a 2 by 2 non-singular matrix. Remember, we have got two types, a singular and non-singular. So where we consider the inverse, it is on the non-singular. The reason being a singular matrix has no inverse, all right? So that is for a non-singular matrix, e.g., you're going to use this for an example, solving simultaneous linear equations and use the rotation. All right, this is supposed to be notation here, and use this notation a to the exponent of negative. That notation here is for the what? Inverse of a matrix, that exponent of -1. All right, so that is basically what you are going to have in the presentation, a to the power of -1. When you're given that, you know that you are dealing with a what? An inverse. So like I said, for the introduction part that we are going to actually deal with, it is on the order or the dimension of a matrix. So that is basically the presentation that you're going to have, which if we are to represent or refer to our matrices, they will be in a rectangular format in a rectangular form. So that rectangular form is given in a bracket form like this, where you are going to consider the elements or the numbers inside here as rows and columns. So let's say we are given A, B, C, D, E, F like this. These elements, the elements that are the terms, the letters or the numbers that can be inside, I'm just going to refer them as what? Terms, elements, or just consider any part, all right? So given A, B, C, up to F, a matrix is represented or is given in terms of the rows by columns. So the presentation of the order or the dimension of a matrix must be the number of rows first by the number of columns. How many rows? So the rows are these this horizontal presentation, those are the rows. So in this case, if we are to consider the rows, that is this part with A, B, C, this part here is given as a what? As a row. And we have got this one again as a what? As a row. So we've got 1, 2 rows. That is the number of rows. The columns are the vertical present. This vertically present. Those are your columns, all right? If you are to present columns that are vertically. So in this case, we are going to consider as what? Columns. That is AD like this. This one, it is a column. All right. Here we've got another column. And here another column. So that is a column, a column, a column, like that. So how many rows do we have in order for us to state the order? In order for us to represent the order, it's how many rows? How many? 1, 2 from what we have. 2 rows. By what? How many columns? 1, 2, 3. We saw that we've got what? 3 columns. So it is a 2 by 3 matrix. That is the consideration. So it is a what? A 2 by 3 matrix. The number of rows versus columns. So you can even write 2 by 2 times 3. 2 by 3 matrix. So given any matrix in rectangular form, like I said, you can state the order of that, or they can give you the order, then you're asked now to represent that. Know that you consider what? The rows and the columns. All right, so given something like this, A, B, C, how many rows and columns do we have if we are to state the order of this matrix that we are given? All right, so the rows, remember, that is horizontally given. So here A is a row on its own. This one is a row on its own. B, a row, C, like that. So we've got 3 rows. By what? How many columns? It's only a single column that we have, which consists of what? A, B, C. So that is a 3 by what? A 3 by 1 matrix. Or when it is by 1 like this, you can even write 3 by 1 column matrix. Or you can just write 3 by 1 what? Matrix. Okay, let's consider another part. Let's say we are given something like this, A, B, C, like that, all right? This is what you're given. How many rows? As you can see, it's just a single row, this one, which consists of what? A, B, C. So we've got a single row. How many columns? That's A is a column, B is a column, C a column. These are columns. So we've got 1, 2, 3. So this one is a 1 by 3 matrix. Just like that. the number of rows versus what the number of columns. So I want you to work out many examples as much as you can. All right, given A, B, C, D like this, how many rows do we have from this matrix? Rows by what? Columns. That is 1, 2. So we've got 2 rows by what? How many columns? That is 1, 2, and 2 columns. So this is a 2 by 2 matrix. All right, or you can even write as a 2 by 2 square matrix. All right, 2 by 2 square, like what you're forming. Remember, we are saying they form a rectangular form, but in this case, this is no longer a rectangular. It's a what? It's a square. With the shape that you are forming is a square because it is what? Same number of what? Rows to the number of columns, so that it is also called what? A 2 by 2 square matrix. Remember, I said matrices are rectangular ways format, a rectangular form that is being used, but in that case, you have formed what? A square. So that's basically what you're going to need on the order. Please revise as much as you can, all right? If there is any question that you do not understand, let us communicate. That's why we have got the community and also the comment section on the YouTube. So let us utilize that as for communication purposes, all right? So I'm going to leave you guys for now with this information. Then we're going to meet again with the same topic, working with another part, which is going to be on addition and subtraction of matrices where appropriate. So make sure that you follow up the videos as they are in the playlist. Work out with the playlist so that you do understand from this video, I'm going to follow this one, from this one, I follow this one. If there is a playlist which is not complete, let us communicate on the comment section so that I fill in that playlist. Or if there's a playlist that you are searching but you can't find, let us communicate. All right. So that is it. Till we meet again.